So when you have a binomial probability distribution that behaves according to this formula, it turns out there are some really nice formulas for mean and standard deviation. The mean is just n times p, trials times probability of success, and the standard deviation is square root np1 minus p. So for example, if n is 10 and probability of success is 0.4, we want to calculate the following. First, mean standard deviation. So our mean here is just going to be n times p, which is 10 times 0.4, which is 4. So 4 successes on average. And then our standard deviation sigma is root np1 minus p. So 10 times 0.4, and then 1 minus 0.4 would be 0.6. Let's compute that on the calculator. So we've got square root 10 times 0.4 times 0.6, 1.55 to 2 decimal places. Calculate the probability of 2 successes using the formula. So this is n choose x, n is 10, and x is 2. So 10 choose 2. This is probability of 2 successes. And then p, our p is 0.4. So 0.4 then gets an exponent of 2. So this exponent matches here. And then 0.6, this will be 10 minus 2, or 8. And let's go ahead and compute that on the calculator. So we need to do 10, and then math, probability, and then 3 is NCR, and 2. And then we are multiplying by 0.4 gets squared, and 0.6 to the 8th. 0.4 squared times 0.6 to the 8th. So 0.1209. Now the TI-84 actually has a distribution calculator that's built in. So the distribution menu will also calculate this. You go to second variables, and then we're calculating a binomial probability, so it's binomial PDF. You put in n, p, and x. So we will go to second variables, and then scroll down to binomial, which is right there, A, PDF. And our trials were 10, and our p was 0.4. And our x value we're interested in is 2. Paste it. And then if you don't get the menu, you'll have to enter, when you press binomial PDF, it'll display the parentheses, and you'll have to enter 10, comma, 0.4, comma, 2. And then enter, and there's our same 0.1209. So this is binomial PDF. And then that is going to be 10, comma, 0.4, comma, 2. And still 0.1209. But the distribution menu is a lot easier. Probability x is no more than x, or no more than 5. So that's saying probability that x is less than or equal to 5. And for less than equal probabilities, you can use binomial CDF. C stands for cumulative, so it adds everything up to this x value. So binomial CDF gives a less than equal probability. So this is going to be binomial CDF trials are 10, p is 0.4, and x is 5. Let's key that in. So second variables, scroll down to binomial CDF, which is B. Trials are 10, P is 0.4, x is 5, paste it, enter. 0.8338 rounded. It's pretty typical to use 4 decimal places on these probabilities. Probability x is greater than 3. So this is probability x greater than 3. So if you have a TI Inspire, it'll have, you can select a greater than, but 84 to 84 CE, 83, they will only do less than equal with binom CDF. So what we have to do is use a complement rule here. We do 1 minus the probability of the complement. So not greater than 3 would be less than equal 3. That's the opposite. And then this we can do with binom CDF. So this will be 1 minus binom CDF. And then it'll still be the 10, the 0.4, and then 3 is our x. So let's compute that. So we can do 1 minus second variables, go down to binom CDF. There. 10 and 0.4 are still in there. We just have to change the 5 to a 3. And 0.6177. So for a strict greater than, you have to change to a less than equal. Between 2 and 7. So this is probability that 2 is less than x is less than 7. So that's the same thing as saying probability if you're between 2 and 7, that would be 3, 4, 5, 6. So x equals 3, 4, 5, or 6. So we have to write this in terms of equal or less than equal probability. So we could do probability of 3, 4, 5, and 6, like we did probability of 2 here. So we could do binom PDF 4 times. Or you can do less than equal 6, which would be 1 through 6. So do CDF up to 6, and then subtract out, well actually 0 up to 6, and then subtract out 0, 1, and 2. So that's going to be binom CDF (10, 0.4, 6). So that's the probability of 0 up to 6 minus binom CDF 10, 0.4, 2. So less than equal 2. So again, what we did here is probability x is less than equal 6 minus probability x less than equal 2, and that leaves 3, 4, 5, and 6. So let's go ahead and key this in. So second variables, go down to binom CDF there. So we need binom CDF with 6 first, and then minus, and then go back in second variables, scroll down to CDF, and then put in our 2, excuse me. And enter. 0.7779. And then the probability x is more than 1 standard deviation below the mean. So that's saying probability that x is less than the mean minus sigma. Well, we know what mean and standard deviation are here. Our mean was 4 and standard deviation 1.55. So this would be x less than 4 minus 1.55. And 4 minus 1.55 is 2.45. So that's the same as saying what's the probability that x is strictly less than 2.45. Well, this random variable only takes on whole number values, so if you're less than 2.45, that means 0, 1, or 2, but not 3, because 3 is bigger. So this is the same thing as the probability that x is less than equal to, and then we can get that with binom CDF. So this will be binom CDF, 10 is our trials, 0.4 success, and we're summing up to x equal 2. So let's go ahead and key that in. You should key in with me. Make sure that you're getting the same answers. So second variables come down to binom CDF, and 10, 4, and 2, 10.4 and 2, and enter 1673. And we've got it. So lots of different examples. They're using binom CDF and binom PDF. PDF is only for equals. CDF is only for less than equal. So everything else that's not one of those, you have to write in terms of equal or less than equal.